Hey guys, welcome back to my channel. Today I am going to teach you how to design a simple circuit using ECDA and convert it to the PCB layer and wave it through the 3D viewer. So let's get started. So here I am in the software as usual, ecda.com. You can search in Chrome or Microsoft Bing, any of the engines. And if you don't know the basics of this software, I got you covered. And I have the video of the basics of this software. So here I'll put the link down in the description, or you can click the notification up in the video, and yeah, you can watch it and learn the basics of the ECDA design. So I'm going to click ECDA designer and let's go. And here we have here I have my first, in the first video. If you watch the first video, I created this basic introduction, and I'm going to click sheet 1. And here today, as I said, we are going to build a simple circuit. So I'm going to get my ingredients, get my components, I'm sorry. So yeah, so through hole 5mm LED, a switch, and a screw thumb. Always try to do this by yourself. And here from now on, I'm going to fast forward. So here I placed my the screw terminal, and I'm going to name them. This thing is LED 1. Oh, what's that? D1. This is switch 1, and this is going to be the power switch. And yeah, now let's connect the power. And today I'm going to use supply flags and net labels, not the wires, because using net labels and supply flags are more easier than using wires. So yeah, I'm going fast forward. So here we have a simple circuit. Oh, I messed up. So here we have the simple circuit, and as you can see, here's the power, and the first terminal, the first section of the terminal is going to be 3.3 volts, and the second part is going to be ground. And here we can see the switch, and here's the supply of 3.3 volts onto the second pin, and first pin is connected with the no connect flag, and these two pins are also connected with no connect flags. And here we have the LED plus. It's connected to 3 poles, and when you click the SPDD switch, it's going to connect to the 3 volt, and it's going to be closed. It's going to be a closed circuit, and from that the LED plus goes to the LEDs plus terminal. And if you don't know how to identify the terminals of the LED, like what's the negative terminal and what's the positive terminal, to identify the positive terminal, this big side, the triangle's big side is the LED's anode. Anode means the positive side of the LED. And there's another factor, and for the negative terminal, you in the negative terminal, the tip of the triangle is pointed towards the negative terminal, and as you can see, there's a line over the negative terminal, and that's also a way how to identify the negative and positive terminal. And the positive terminal doesn't have a line, and like that I connected it. So this is a simple circuit. Later on we'll build a motor controlling circuit, like using the L293D chip, and power it using Arduino. I hope to do some Arduino lessons. Yeah, let's see. And just like this, it's done actually, and I'm going to save it. Saved successfully. And now the part where we are going to convert this schematic to the PCB layer. So in order to do that, you need to go to this fabric design tool in this toolbar, and when you hover your mouse, your cursor on the surface of the design button, you can see there is this convert schematic to PCB, or you can just click Alt P as a shortcut, but I'm going to click this, and this is going to convert the PCB to the convert schematic to the PCB layer. So let's click it. How it's converting. And here is our circuit. As you can see, I think you cannot see because it's oh, now you can see. You can see that, yeah. And now you can see. You can first of all you can customize your PCB's board outline and the copper layers. 2 is enough for now. 2 is enough. It's alright if you get one, but we are focusing on 2 layered boards. That's the whole point of PCB. And units, millimeter, not 13, I don't know. And this is rectangular. We can change it to circular, round rectangular, or a custom shape. So for this I'm going to go with rectangular and apply that to the PCB. Oh, it looks square. Yeah, it's alright. It is a square. And now you can drag them just like clicking on the component you need, and you can just drag them. That's it. Just like how you drag these components. Click on them, hold and drag. So, and as you can see, there is something violet or purple colored outline in the my workspace, and that's the board's outline. Okay, so yeah. And how to rotate this is very simple. You just press space, like in these components you just press space. So yeah, like that. And now you can place it anywhere you like, and this is the silk screen. Yeah, I'll teach you about that later. So first of all, let's place it according to your need. And you can extract the switch, the name of this thing using just click on this and click on the text, then it's selected, and you can also delete it and type another thing. So I'm just going to type switch. I'm going to let that there, just like that, and you can rotate it using the spacebar. So now I'm fast forwarding, and you can place it according to your it's your choice. So here, as you can see, I've aligned all the components as my need, and I told you about something called silk screen. or the component legend. And what is the silk screen, if you ask me? Silk screen is the, if you take out a circuit board, you can see like the most common circuit board color is green, and there will be some white like white ink and white text all around your PC, all around the circuit board. And if you can only do this if you can, like no, yeah, if you have a broken PCB, then you can do this. If you can desolder the PCB, you can see the component in there. There is the component. There is a print that where should the component go. I mean, like this is often used to the it's often used to the know where the what are the components and where they are gonna be placed, and that's why the first first use of the silk screen. And second, you can decorate like type your logo and put your logo like that. You can decorate your PCB using silk screen. So as I said, the silk screen first use is to know where your component goes on the PCB and what is that component. So here I know what this is, but you can actually put, if you like a code name for this screw terminal, I can put ST if you want. Yeah, and now let's add let's add my logo to the PCB. So how to add that? First of all, my logo is not text, it's in PNG format. So I'm going to click on image and select an image file, and then I'm going to select my logo, and as you can see, it's a bit blurred. So as you can see, the outcome is like this. So my logo is like that. So it cannot print in colors, so that's the main thing. So like if you have that shadow like thing in your background, so it's gonna look like this. So I'm not going to use that. I'm just going to type using text. And if you use a logo, make sure that the background is transparent, or else it's not gonna work properly. And if you don't know how to make a PNG or any type of image transparent, you go to the website called remove.bg, and from that you can upload an image, and this works pretty well to me. And yeah, so here's my background without the transparent background, and as you can see, it works really well. So like that, and here's my PCB connector. Now I'm going to just type some text. I'm going to fast forward this. How do you first of all, how do you edit text? Is you just click on them and this text box appears, and you type whatever you want in there. And now I'm going to fast forward this. So here we have it, and as you can see, it doesn't fit on my board. So actually you cannot resize this as the text box you usually use in Word. Like you can resize that using the points on the text box, but in this software you cannot do that actually. So in order to small this, we can use this height. And when you click on that, and there will be this text properties which thing appear in here, and here there is this height, and you can change the height according to need. So if I click 1, it's going to change with millimeters. So, and yeah, still it's very yeah, now it's all like that. I'm going to my the logo here, and as you can see, this silk screen is in yellow color and this thing is in red color. And actually, if you think hard, this is not silk screen and it's not going to print like the silk screen. And in the red area, it's going to print as it's going to leave like the copper. That means the PCB manufacturer detects is as the copper. So that's why it's like going to be like the copper wire. So in order to achieve the silk screen, we click on that, and in the text properties we can see there the first thing is layer, and I can select it. As you can see, it's the top layer, and to in order to avoid that and at the silk layer, I'm going to choose top silk layer, and then it's yellow, and that means it's going to be silk screen. And here it's very blank, so I am going to add a logo or something I have on my image. I want to show you how to add. Yeah, ECDA. Let's add the ECDA. I download the RemoveBG preview and I open that, and it works, you can see. And I'm going to insert it, and as you can see, this logo is pretty big, really big. So in order to scale this down, here as you can see, there is the width and the height, and you you can resize this respectively to this width and height. So I'm going to do that respectively, or else you will end up like squished a logo. So yeah, actually that's a pretty straight square, so I'm going to do this like 32, 5 and 30. And as you can see, it's now scaled down, and again I'm going to scale it down. Okay. Like that, you can scale it down. And now 15 is 7.5, and this is going to be 8 millimeters. And now it's in the scale that you can put in here. And as you can see, it's also this appearing as the and as the red color thing. That means the top layer, and that means it's going to be copper. But here I want the silk screen, so I'm going to change that. Just like the text, you can change that. In the image attribute, top layer is going to be top silk layer. Now actually we can add some effects. Let's try to add some effects. I'm going to copy this and put it behind that, and let's see top layer. Oh yeah, as you can see, now it's in like here you can see that now there is a slide effect. What I actually did was I just copied and moved it a little bit to the right, and I converted it to the top layer. And actually the silk screen layer is on top of the top layer, so don't worry about that. The top layer won't come up, so I'm going to do that for the CD as well. Like that, top layer. Oh yeah. But the thing is that if you do this effect, make sure that there are no wires going under them, because this is copper and it's going to be conductive. And if accidentally it connects to positive and negative terminals, positive and negative current, it's going to be short circuit and your PCB will be severely damaged. And if you don't have any wires going, then do that, and that's a pretty cool effect. And now it's done. It's almost done. And here we can see the wirings. Here is the 3-volt, the ground, and here's the ground and the LED glass. And here's the switch. Now, if you've seen circuit boards very closely, the wiring arrangement is pretty much neat, and it's not like this. It's very neat. Not pretty much, it's very neat. And here it's not that neat. It's like some wires drawn through some terminals. So to get that circuit looking look to our PCB, we need to route it. Actually, you can manually route it if you like, but if you are a beginner, I would say to auto route it, because I still use the auto routing tool, because that's very cool. And yeah, so to route, I have on route and auto route. I have on auto route and I click auto route, and here you can see the auto router config display, the auto router config window. And here when you these things are not really necessary. Here in the router server, as you can see, there are two options, cloud and local. When I try cloud, it takes a lot of time, and I never successfully routed my PCB. We are using the cloud version, so I always install the local auto router. So I will show you how to download the local auto router. In here, as you can see, there's a link called install local auto router, and I will click that, and then you will be redirected to a website. And as you can see, there are everything you need to know about the route tracks, track routing. And as you can see, everything is here. Actually, this is a very decent thing if you want to read, but here. And here we have the local auto router. So to do that, the local auto router is here, and you can download it using this link, and it's a zip file, and you can unzip it, to a file, unzip it, and there will be a file appearing in your thing and in your desktop downloads. And I have it on my downloads file in a folder called ECD router Windows. And when I click that, there is this thing, and this is the auto routing file. And here we have this Win64 Windows batch file, and that's the auto routing application anyway. And when I click that, there will be this exe appearing, and it's a code. It's a programming. It's a program, and let it do the job. And again, when you download it and open the Win64 file on that folder, you again click auto route, and here, as you can see, the software automatically detects that local router is installed and is available. So you click that and you run. Now you are going to get that amazing finish, just like the circuit board. As you can see, it's pretty decently drawn automatically. And to save this, I'm first of all, if you need to watch the preview, you can you always need to save it, save the PCB and then watch the 3D. And in here I forgot to tell, you always need to save and then convert it, the schematic to PCB. So now I'm going to save this, and now we can look at the 3D view. Here, how to look at the 3D view, if you ask me. Here, as you can see, in here there's this 3D, and if you click on that, the 3D view will be generated, and here you can look at your 3D view. And as you can see, that's shaded, and that's actually a copper layer, I guess, and that's not exposed, and that's pretty cool, isn't that right? ECDA and also electronics. So that's how do you build a simple circuit, and that's how you build a simple circuit. So I think you knew how to do this, there's all stuff like PCB design and PCB editing. In the next video, I am hoping to introduce the L293D chip, which is a motor controlling chip, which is very useful in creating robots such as the obstacle avoiding car, the line following bot, and many more. You can actually like, if you are creating bot that moves, you need an L293D motor controller. If it is like, if you wanna do it on command, just like think about like that, then you always need a L293D chip. So in the next video, I am going to teach you about that L293D chip. So I hope you learned something today. If you think this is very educational, and if you want to support me, please subscribe and like this video, share it with others, and for last, thanks for watching.